This is Algebraic Reasoning, Chapter 1.8, Exercise 17 through 23. The Section 1.8 in our book has to do with cubic functions from a table. And my last video, which was about 40 minutes long, went over a few problems. And because of the complexity, relatively, of finding the elements of a cubic function, took quite a while. In this exercise set, we have three real-world sets of problems. There's 17 and 18. That's one set. There's 19 and 20. And finally, the set that has to do with these blocks here is going to be 21 through 23. What I'm going to do is come back to this middle set here, 19 and 20, and just work this out and have that be suffice as an example for the remainder of the work here. Now, first thing we're going to do is we know that we have a cubic function because they communicate that to us. And so we set about the task here. In finding a cubic function, the first thing we're going to do is find our first differences. And our first differences, we have 3.45 minus 0, so that's going to be 3.45. The next one we have is 6.6 minus 3.45, so that's going to be 3.15. Then we have 10.65 minus 6.6, that's going to be plus 4.05. Then we have 16.8 minus 10.65, which is going to be 6 plus 6.15. And then the last one we have is 26.29 minus 16.8. That's going to be plus 9.45. So these will be our first differences here. Now, one thing I did not do, as I did in the beginning, is I didn't tell you what the standard form of a cubic function is. Well, it's going to be this one up here, f of x equals a x cubed plus b x squared plus cx plus d. And we know what these a, b, c, and d are, and we have found our cubic function. Well, the first thing we look for, if it's readily available, is our d. And our d is really our y-intercept. So in this case, where our package pounds is 0, we have our output of 0. So in this case, d is going to be 0. So now, after that interlude, we're going to go back to found the first differences here in this relation. Let's go find our second differences. Okay, the second differences, we subtract one from the other. So we take 3.15 minus 3.45, we're going to get negative 0.3. If we take 4.05 minus 3.15, we're going to get plus 0.9. Next, if we take 6.15 minus 4.05, we're going to get plus 2.1. And the last one we're going to look at here is 9.45 minus 6.15 is going to be plus 3.3. Plus 3.3, okay. And these will be our second differences. And since they are not the same, we say, okay, well, we don't have a quadratic function. The last one we're going to look at is our third differences. And 0.9 minus negative 0.3 is going to be plus 1.5. And then 2.1 minus 0.9 is also going to be plus 1.2. Did I say 1.5? I'm going to say plus 1.2. then 3.3 minus 2.1 is also going to be plus 1.2. So these are all the same, which is indicative of a cubic function. So I'll put down third difference here. Okay, the next equation we're going to look at to find the ABCD. I'm going to write this up here. Okay. That to find what A is, and that's what we're going to do. We have our third difference is equal to 6A. And our third difference is 1.2. So 1.2 equals 6A. So dividing by 6, A is equal to 1.2 over 6, which would be 1/5, or 0.2. So I'm going to come up here and say, okay, A is equal to 0.2. Okay, the next one we're going to do is look at the next equation, and I'm going to kind of make space over here to the left of the table. So I'm just calculating the second difference. Okay, the second difference is going to be this thing right here, this negative 0.3. Okay, and this negative 0.3, our first second difference, negative 0.3, is equal to 6A plus 2B. And so we bring down negative 0.3, which is our first second difference. And 6A we already calculated to be 1.2. So 1.2 plus 2B. And we subtract 1.2 from both sides. We get negative 1.5 equals 2B. Well, if we divide by 2, we get B is equal to negative 0.75. So I'll put this over here. B is equal to negative 0.75. Or sometimes you can see it written as 0.75. Okay, so that's going to be our B value. And the last thing we're going to look at is our C value. Just for sake, I'm going to write that in a color-coded thing too. Okay, the C equation has to do with our first difference here. Okay, between x equals 0 and x equals 1. So 3.45. So 3.45, our first difference is equal to A plus B plus C. So I'm bring down 3.45, and A is equal to 1.2. No, it's not. It's equal to 0.2. Well, and then B is equal to negative 0.75. Then we have plus C. And combining on the right here, negative 2 minus 0.75 is going to be negative 0.55. So on the right we have negative 0.55 plus C equals 3.45 on the left. If we add 0.55 to both sides of this equation, 3.45 plus 0.55 is 4. So C is equal to 4. So I put C is equal to 4 right here. So now I'm going to write the cubic function down below using this ABCD, and that's going to be f of x. Well, it's price to mail package, so that's going to be P is equal to, and A was 0.2, so 0.2 w cubed, and we're going to have b is negative 0.75 w squared, and c is calculated to be 4, so plus 4w plus 0. So this is going to be our answer for our cubic function right here. Now I'm going to go do problem 20. For this, I think I'm going to go to the calculator. It says use your cubic function to determine the cost to mail a 6-pound package. So we have our input values are pounds. So I guess if we wanted to, we could do the third difference and second difference and first difference. That would be pretty easy to extrapolate. What I'm going to do is just go right from here to our calculator and just put in 6 to this equation. That's kind of taking an easy way out, but that's what I want to do today. So I'm going to come here and get that function there. Okay, good. So we have 0.2, let's try again, 0.2. We have x to the third power, and we're going to have minus 0.75 x squared. We're going to have plus 4x, and our y-intercept is 0, so we ought to be good here. We just take a look at it, press enter. We can kind of see this here. If we looked at a graph, we could go upward to find that. We could probably do a graph trace to find it. What I'm going to do is take advantage of the table view, press Control T, and if we get an input value, where we get an input value of 6, that's going to be our answer, right? So I get 40.2. You see along the line, all these other points were met. So 40.2 is what we're going to call. So we say 40.2 ounces will be our answer there. Now, of course, in our calculator, we could have taken the data and run a cubic regression, but we're trying to get beyond that to sort of the bare bones way of doing it, which is how we came up with this function. So take a look at these other problems. This earlier set here, question 17 through 18, is simpler, and the last one here with the blocks, I think, is similar to the one we did in 18 and 19, or 19 and 20 rather, as far as terms of complexity. So good luck, and thanks for viewing.